Oops. All right, so we're covering 9.6 to start with, vectors in space. And if you have a book and want to turn with me to page 639, page 639 is the page I'm going to be working from. And one of the first formulas that we're going to need is a formula to find the distance between two three-dimensional points. The distance formula for 3 dimensions, an x, y, and a z. So that formula looks like this. It's going to be x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Yeah, so it's pretty much like the two-dimensional distance formula. You just got that extra z component thrown in there. Okay. You know what I think? Let me go ahead and give you the formulas first, and then we'll do examples. Is that okay? Okay, so next we're going to need the formula for a vector given its initial point and terminal point. And that's going to be x2 minus x1 I, y2 minus y1 j, and z2 minus z1 k. Okay, so that's finding the three-dimensional vector if you know its initial point and terminal point. We're going to need a magnitude formula, and that is square root of a squared plus b squared plus c squared, if I'm not mistaken. Let me check that real quick. Magnitude. Okay, good. I didn't lie to you about that. Okay, so again, this is magnitude. And we also have a unit vector, but the unit vector formula for 3 dimensions is exactly the same as it is for 2 dimensions. The unit vector formula doesn't change. And the dot product, didn't we do dot product last time? And the dot product formula is basically the same as it was last time, except now you've got 3 components. So it'll be A1 times A2, B1 times B2, and now you've got the Z component, C1 times C2. There's your dot product. And then there's another thing. It says find the direction angles for each vector. The direction angle for each vector. Yeah, and I'm going to have to copy these down out of the book. I don't keep these stored. Cosine of alpha is going to be A over, that sure looks like the magnitude of V. I'm going to write the abbreviated version if that's okay, with showing the magnitude symbol, and then you know to go and plug into here, right? With this given, y'all know what that means? Magnitude, okay. And then we're going to have Cosine of beta is going to be b over magnitude of v. And cosine of, what is that, gamma? I did the best I could. C over magnitude of v. And let me scroll up just a little bit. And those bad boys are when it says find the direction angles of each vector. Finding the direction angles. All right, so do y'all realize that most of this stuff here that we're doing in this section is plug and play? Y'all realize that? It's whatever they give you, and then whatever they ask for is going to identify the formula to use, and then you just plug the numbers where they go. Got it? And y'all are pretty good at plug and play? Or for some of you, is it plug and pray? Yeah. All right, so let's start with number 15. That'll be our first example. Number 15. We've got P1 is the origin, and P2 4, 1, and 2. And the instructions say, find the distance from P1 to P2. Finding the distance, that means we're going to use the distance formula. And if you're just finding distance, does it matter which point you label with the 1s and the 2s? If you're just finding distance, it doesn't matter which one is x1, y1, z1, x2, y2, z2. Now, if it says find the vector where you've got x1 and x2 here, this does make a difference because the x1 has to be the initial point and the x2 has to be the terminal point. Got that? But if you're just finding distance, it doesn't matter. x1, y1, z1. Let's say that that's going to be the first x, y, and z because it's the origin. And then we got x2, y2, z2. Second point. Finding the distance. We're going to plug and play. Here we go. 4 minus 0 squared plus 1 minus 0 squared plus 2 minus 0 squared. And if I'm not mistaken, that's just going to be 4 squared plus 1 squared plus 2 squared. And this is a great opportunity for you to use your calculator. Survey says? Not everybody at once. Can I have it as just a square root? Ophelia, is that what you got? Square root of 21? And then did you hit the SD button? Oh yeah, you got the decimal approximation. And y'all do understand, since this is a distance, this could be like so many miles, right? And you do understand you're not going to call somebody and say, hey, I just drove square root of 21 miles today. Probably not going to say that. So you do need to know how to get the decimal as well. Anybody have any questions about that problem? Do I need to do another example of finding the distance between 2 points? Or was that good enough? Okay, that's satisfactory? Good. We'll move on then. Number 31. Okay, now we've got P, point P, -2, -1, 4. And we've got point Q, 6, -2, 4. And the instructions say the vector V has initial point P and terminal point Q. Write the vector in standard form. And for 3 dimensions, that's AI plus BJ plus CK. Like Louis, okay? Louis CK. All right, so does it matter which one of these I label with X1 and X2? Oh, it does. Now it does. The initial point has to be X1, Y1, Z1. And the terminal point has to be X2, Y2, Z2. And it did say find the vector. So we're going to be plugging into the vector formula up here. And when we get done simplifying, it will be standard form. All right, here we go. We've got 6. Oh, look out. Minus a negative. Makes it a plus. 2. Everybody see that? Plus Y2. -2. Look out. Minus a negative. Makes it a plus 1. J. Okay. Plus Z2. That's going to be 4 minus 4. K. I have a bad feeling about K. I think he may be going away. 6 plus 2. I've got an 8I minus 1J, which you can just put minus J. And I don't have any K. 4 minus 4 is 0. And there's the vector. That's it. That's done. So much fun. And if you just look at that, the way it's written, it looks like a 2D vector, doesn't it? Just an I and a J. I guess if you wanted to, you could put 0K. I don't know why you would, but you could put 0K. And does anybody need to see another example of that type of problem? Or was that easy enough? Yeah, yes or no? Okay. If you're good, I'm good. Let's do the next problem. That's going to be 33. Let's see here. 33. And this time they give me a vector, 3I minus 6J minus 2K. And it says find the magnitude. Find the magnitude. So let's go ahead and label this. A is 3. B is -6. C is -2. And I do have a magnitude formula. And we're going to plug and play. Here we go. Square root of 3 squared plus -6 squared plus -2 squared. And what a great time to use a calculator. Don't forget, negative numbers have to go in parentheses. And I would like the exact value. 7? Even? It actually worked out to be just a 7? That's freaking cool. And you know what magnitude is, right? Magnitude is the length of the vector. Don't forget that. Magnitude represents the length of the vector. And do I need to do another example of that kind of problem? Or was that good enough? Are y'all telling me that one example of each one appears to be getting it across? Okay. Huh? It is, right. But you got to know which formula to use. You sure do. Oh, and then it helps to have a calculator too. All right, let's see. What's next? How about number 39? 39. And for 39, we've got a couple of vectors. Vector v, 3, negative 5, and 2. And we've got vector w, negative 2, 3, negative 2. And for number 39, it says find 2v plus 3w. V plus 3w. So that's going to be 2 times vector v, but vector v is 3i minus 5j plus 2k, okay, plus 3 times vector w, which is negative 2i plus 3j minus 2k. And y'all see again that that is just plug and play. Now let's distribute and combine like terms. Here we go. 6i minus 10j plus 4k minus 6i. I got a bad feeling about this. Plus 9j minus 6k. I think this answer is going to be blind. Yeah, no i's. 6i minus 6i. No I. Minus 10j plus 9j. And then I've got a plus 4k and a minus 6k. And there's the answer. Too easy. Too easy, right? Anybody have any questions? Whoo, if it just stay this way. Just stay like this. Are y'all ready to go to the next one? Number 47 is next. 47. And they give me vector v, 3i minus 6j minus 2k. And what does number 47 want? It says find the unit vector. 47 says find the unit vector. So if you'll remember from section 9.4, I think the unit vector was given in 9.4, and that is vector v divided by its magnitude. This is the formula to find a unit vector. So that's going to be the original vector. All of that vector just copy and paste to the top. And in the denominator, we're going to have the magnitude formula. 3 squared plus negative 6 squared plus negative 2 squared. And I'm going to need somebody with a calculator that knows how to use it to calculate the magnitude. Say that again. What? Yeah, the bottom part. I need the bottom part. I need all of this denominator, don't forget the parentheses for the negatives. And you got 7? What? It's the same as this?
Yeah, 7.
Holy crap, I didn't even notice that. Anybody else notice that? Those are the same vector. And we just did the magnitude. Okay, you're sharp. I'm sorry, I didn't realize. All right, so here we go. For the answer, the unit vector is 3/7 I minus 6/7 J minus 2/7 K. Yeah, whatever the denominator is, you have to give it to every term in the numerator. Yeah. And the reason we need to do that is so that it's in standard form. Okay? And then I'm going to ask you math trivia, something I covered in class. Let's see if you remember. What is the length of every unit vector? Oh, good. You learned. The length of every unit vector is 1. And so what if I apply the magnitude formula to this result? What should the magnitude be? 1, because magnitude is length. And I'm not going to do that. You can do it if you feel like it. Any questions about finding a unit vector? Anybody want to do another one? What's the question?
How do you do J and K in the calculator?
You don't.
Oh.
Yeah. On the Casio, you can't do a J and a K. Yeah, you can't actually. What do you want to put this in right here?
Yeah, I just want to see what it would throw out.
I don't think you can do. Let me look at the calculator real quick. It has A, B, C, D, E, F, X, Y, M. I don't see a J and a K. Yeah, so unfortunately, I don't think that's going to work. Okay, so do I need to do another example of that? Find a unit vector? Or was that sufficient? Anybody want to see another example of that? Okay, fine. We'll do one more of those then. Where am I at on space? Okay, let's squeeze one in right here. Oh, and can I make it up? Yeah, this is going to be my vector. And let's call it vector, what's a good name for it? Huh? Oh. Vic? Can I do that? Now give me a single letter. O? Okay. Oh, let's make it a fancy O like that. O. So this is vector O for O'Neill. And let's see. Let's make it exciting. About 9I minus 7J plus pi K? Maybe not. Maybe not that exciting. How about 2K? Okay? And let's see if we can find the unit vector for that guy. 9I minus 7J plus 2K. Boy, the numerator's easy. Just copy and paste. And the denominator is the magnitude. Man, I hope it comes out to be a nice square root. Does it come out to be a nice square root? Square root of 134? I didn't square root nicely. That's still radical, dude. Anybody else get square root of 134? Oh, snap. All right, so that's going to be 9 over square root of 134 I minus 7 over square root of 134 J plus 2 over square root of 134 K. And you know what I'm not liking about that? Yeah, those are all effed up SOB. Y'all know what that means, right? Fractioned up square root on bottom. Yeah, and we can't have that. So let's rationalize 9 square root of 134 over 134I. 7 square root of 134 over 134J. And 2 square root of 134 over 134K. Whew, that is nasty. Nasty. But do you see how it works? Let me ask you this question. How'd you like to take this result and plug this back into the magnitude formula to prove the length is 1? How'd you like to have to go through and square each one of those and add them up? Yeah, that would be fun. That would be a lot of fun. Yes?
Can you simplify down to square root of 134 over 67?
And you probably should do that, yeah. Yeah, so the 2 and the 134, what did you say it simplifies to?
Square root of 134 over 67.
67. Yeah, you probably should go ahead and reduce that. That's using your good math etiquette. Yeah. And just for checking, 7 and 134 doesn't reduce, and 9 and 134 doesn't reduce. Okay. But yeah, those fractions should be reduced to lowest terms. All right, so can I go to a new page? Anybody still need that up? All right, here we go. Add a page. We're still on 9.6. What number did I just do? 47? But I mean before the one that I made up. All right, so let's go to number 53 next. Here we go. Vector V, 2I plus J minus 3K. And I also have vector W, I plus 2J plus 2K. And the instructions say find the dot product. Find the dot product. All right, so did I have a formula for dot product? I think I wrote it down, didn't I? It was A1 times A2 plus B1 times B2 plus C1 times C2. And do y'all see how nice it makes it if you go ahead and stack those? If you stack the vectors on top of each other, it lines up the numbers that get multiplied. Here we go. So 2 times 1 is 2. Again, 2 times 1 is 2. And what about negative 3 times 2? Negative 6. Add them up. Did y'all see? That went awful fast. Did y'all see how freaking easy that was? Because I can go through it again if I need to. That's done. That's the dot product.
So for the dot product for a vector in space, we also include C1 and C2?
For a dot product, what did you say?
Do we also include C1 and C2? So we have A, B, and C?
Exactly. Yeah, if it's 3 dimensions, if it's got a I, J, and a K, then you have to multiply all of their coefficients and then add them up. And that is the dot product. So again, did y'all see? You're just multiplying up and down, and then once you get those products, you add them up. Now, let's do this. Let's find the angle between those two vectors. Let's find the angle between those two vectors. Now, can we graph three-dimensional vectors and look at the angle to see if it looks right? Remember, we did that on two-dimensional vectors. We graphed them and said, yeah, that looks about like 30 degrees or whatever. I think this is going to be a little bit harder to graph three-dimensional vectors and then look at the angle between them. Yeah. So I would like you to know, though, that the formula for finding the angle between two vectors does not change from 2 dimensions to 3 dimensions. And does anybody need me to write that formula down again? Okay, I will. So the formula was inverse cosine of the dot product divided by the magnitudes multiplied. Finding the angle between two vectors. It's the inverse cosine of the dot product divided by the magnitudes multiplied. All right, here we go. Have we already found the dot product? Yes, so the numerator is -2. However, I do not know the magnitudes yet. And so let's come down here and let's go ahead and calculate the magnitude of V and W. So for the magnitude of V, that's going to be square root of 2 squared plus 1 squared plus -3 squared. And for the magnitude of W, that's going to be square root of 1 squared plus 2 squared plus 2 squared. Let's see, 9 and 4 is 13, 14. I'm thinking square root of 14 for the first one. And 4 and 4, 8 and 1 is 9. Hey, that comes out to be a nice whole number, 3. Is that right? Questions? Anybody have a question?
This is only the same question.
This is all part of number 53. But do you understand it's part A and part B? Part A said find the dot product, and part B said find the angle between the two vectors. You know what? Let me set that off, okay? So that doesn't look quite as confusing. Let's do this, and let's call that part A, and this is part B. I don't know, does that make any difference? So all of this in the red box is part A, and then everything outside is part B. Finding the angle between the two vectors. Has anybody calculated the inverse cosine of -2 divided by 3 times square root of 14? Oh, and I'd like that in degrees, so you need to be in degree mode. And how about rounded to the nearest tenth? Anybody else going to verify 100.3? Oh yeah, boy. Nice to have verification. And you know the way you do that in 3 space, the vectors are like these pins here. And one of them's, I don't know, heading off into this direction, and this one may be heading off into this direction. Can y'all see that? And if you rotate it around and look at it, it looks a little bit bigger than 90. But that's 3-dimensional vectors. Or this one could go like this, and this one could go like this. or like anything like this. Y'all see what I'm saying? We're talking about free space. Whew. Crazy stuff. Exactly. Yeah, so if we were to sketch that, you want to sketch it? I don't really want to sketch it. But. Yeah, so this would, let's see here, this would be like the X, Y, and then maybe Z goes up and down. And so to sketch this first one, that's going to be 2 in the X direction, 1 in the Y direction, and then -3 in the Z direction. 1, let's see, right there, and then 1, 2, 3. Something like that. So this would be vector V. And then the other one goes 1 in the X, 2 in the Y, and then up 1 in the Z. Something like that. It's hard to do in 3D. Hard to do in 3D. And you know what? I feel so bad about how poorly I drew that I'm just going to do this. Bam. Let's get rid of it. Does anybody need to see another example of that type of problem? Anybody? Because I've got time. Okay, I think I'd like to do one more, just for fun, and since I have so much time. So let's do problem number 51. Oh, I already wrote vector V. Duh. So there's vector V, and here's vector W. Questions? Y'all see the vectors? Anybody have any questions about either one of those vectors? You should have a question. Yeah, that's the question. Where is K in vector V? Well, the value of C is 0. So that value is 0, so the K is not there. Okay, now if you want to put plus 0K for a placeholder, you can. Like this, plus 0K, if you feel, it looks like it's okay now. Yeah. So let's find the dot product. A1 times A2, 1. B1 times B2, C1 times C2. Positive 0. Yeah. And survey says? And we all know what a dot product of 0 means. Remember that special word I taught you? Starts with an O? Orthogonal. If the dot product is 0, the vectors are orthogonal. And what does that really mean? It means the angles between the two vectors are, the vectors are perpendicular. Well, okay, it's not, they wouldn't have a special word for it if it meant the same as perpendicular. Okay, so orthogonal means it's something special for vectors. Y'all know what I'm saying? Okay, normally perpendicular means one line and another line that actually touch at a right angle. But vectors can be anywhere in space, and they can have different initial points and terminal points. So I think really orthogonal means if they were to extend to where they touch, then they would meet at a right angle. I'm sorry. Have a good evening.
Thank you.
You'll be missed. All right, so here we go. Now that we know that the dot product is 0, let's see if we can prove that the angle is 90. So plugging into the formula, that's going to be the inverse cosine of the dot product, which is 0. And does it really matter what the bottom is if the top is 0? I know. So we're just going to put magnitude of V, magnitude of W, and we know that we don't have to do that work because 0 divided by anything is 0. And the inverse cosine of 0 is 90, right? That never gets old for me, that pun. 90, right? Have y'all ever heard that joke? If you get cool, go sit in the corner. Y'all, because it's 90 degrees there. Y'all not heard that joke? Now, number 59. And this is the last problem I have to get through to finish this section. This will be the last one for this section. 59. We've got vector V. 3I minus 6J minus 2K. And this problem says find the direction angles of each vector. Write each vector in the form of equation 7. What does that mean? In the form of equations. Oh my gosh. Okay, so when we get the direction angles, I'll give you equation 7 and show you what they want it to look like. All right, so to find the direction angles, first we're going to notice that this is A, this is B, and this is C. And did anybody happen to write those? I'm sorry, go ahead. Is it really? Oh, good looking out, Matthew. It's a repeat, huh? Okay, well maybe that'll save us some work here. I'm going to have to go back to the previous page and look at the direction angle formulas. What did they look? There they are. Do y'all see them right here? So cosine of alpha equals A over the magnitude of the vector. Now I forgot what it said. So, what did it say? Cosine of alpha equals, and I know what A is, over the magnitude of V. And Matthew, you said that we've already done that magnitude? And what is it from the previous work? Got that? Now, I didn't show the work for this because we already did the work previously. So if you want to get that work, you can go back to the previous page of notes and look it up. And at this point, we can now solve for alpha by taking the inverse cosine. So alpha is going to be the inverse cosine of 3/7. And somebody want to give that to me in degrees to the nearest 10.
64.6 degrees.
Alpha. Anybody have any questions about that? Okay, next, cosine beta. That's going to be B, which is -6, over the magnitude of V, which is -6/7. And from there, we can get beta by doing the inverse cosine of -6/7. And I'd like that in degrees rounded to the nearest tenth, please.
49.0 degrees.
And finally, cosine, whatever that symbol is. I think it's gamma. And that's going to be C over the magnitude of V, which is negative 2/7. And then we can get gamma, inverse cosine of negative 2/7. And is that obtuse also?
Yes.
What is it?
106.7.
106.6.
Oh my gosh, scared the f out of me. How's that? So far so good? All right, now then. Let's see, equation 7. V equals magnitude of V cosine alpha. Let's do another set of parentheses. Is that too low, Amina? Here we go. Is that better? Okay. Vector V is the magnitude of V times cosine alpha I plus cosine beta J plus cosine, I think that's gamma K. And that's what equation 7 looks like. So if it says find the direction angles and then write the vector in the form of equation 7, do I have everything that I need now to plug into this formula? So what was the magnitude of V? 7. And what was the cosine of? Okay, so that's actually going to be cosine of 64.6. Ah, dude, 64.6 I plus cosine 149 J plus cosine 106.6 K. Holy crap. Holy crap. Now, where have I seen something like that before? Where have I seen something like that before? Is it okay if I go away from this for a second? Okay, the first thing I want to do is this, copy, paste, and then I want to go back here. Oh, right here. Y'all see that? That's the M and D formula, magnitude and direction formula. But now that we're doing 3 dimensions, it's cosine theta I. Wait a second, that's sine theta. I better make sure I got the formula right. I did. I didn't lie to you. They're all cosine. But this one was sine theta. Okay. I'd like to check something real quick if it's okay with y'all. Got a calculator in degree mode? Yeah, would y'all push what I say? I want to check something real quick. Will you do 7 times cosine of 64.6? 7 times cosine of 64.6. And what did you get? Was it pretty close to 3? Okay, pretty much 3. And the reason it's not exactly 3 is because we rounded this off, okay? And now do 7 times cosine 149.
-6.
And is that pretty much -6? Okay, so I see what this formula is. This is, to put it in these terms, this is also almost like rectangular form and polar form, if you wanted to think of it that way. Because this is like three-dimensional XYZ axis, and this is like radius and an angle. Y'all understand what I'm saying? If you multiply this back out doing the distributive property, you're going to get this answer back. So if you're wondering, is there a way to check this work? Yeah, you can just multiply this out and see if you get the original vector back. Whew, questions about that one? All of this down here is the final answer, but it also asks for all of these angles too. So those are the intermediate answers. Yeah, it said find the direction angles and then write the vector in the form of equation 7, and they're calling that what I would refer to as polar form as equation 7. How are we doing so far? Questions? If not, then that's going to finish it up for 9.6, and that means that we can skip over to 9.7. And just to put this in perspective, this is the last section of the semester.
That's scary.
Mm-hmm. Yeah, me either. But for me, it never ends because there's always the next semester. And then you start over again. Anybody ever seen Groundhog Day? With Bill Murray? That's my life. Live the same day over and over and over. Yeah, really, I'm not that smart. I've just lived the same day so long. All right, so let's talk about the cross product. Now, I'm pretty sure that in the textbook they give a formula for the cross product, and that formula is big and nasty because I've looked at it already. And if you've had college algebra, then you've done matrices and specifically finding the determinant of a matrix. Yes or no? You better say yes because that's part of college algebra, finding the determinant of a matrix. So if you're going to go to the text and look at what it says, the process of doing whatever the cross product means, it has to deal with finding the determinant of either a 2x2 or a 3x3 matrix. Okay? I had my own process, if y'all are interested. Okay, so I would refer to this as the cross product shortcut. And the only way to really show how it works is to just do an example. So we're going to start with number 15. And we've got vector v, 2I minus 3j plus k. And we've got vector w, 3I minus 2j minus k. Okay. And then what they asked me to find with these two vectors, it says find the cross product v cross w. It is important to note that the cross product is not commutative. Do y'all know what that means? Yeah. It can't go both ways. So if I say B cross W and switch it around, I won't get the same answer. So the order that those vectors are in matters. Got it? So when something's commutative, it means order doesn't matter. It'll go both ways. All right, so let's do V cross W using the O'Neill technique. So what we're going to do is we're going to start with the letters I, J, and K going across the top. And then whichever vector is first on the next row. So vector V, that's going to be 2, -3, and 1. Do y'all see where those numbers come from? Those are the coefficients of I, J, and K. And then vector W, whichever vector is next, 3, -2, -1. So far, so good. And then in order to find the cross product, if you know how to do the determinant of a 3x3 matrix, you just do the determinant. But a lot of people don't remember how to do a 3x3 determinant, and so this is where my shortcut comes in. And what we're about to do is solely for the purpose of the shortcut. It's math magic. It's not mathematics, okay? Math magic. We're going to take the first 2 columns and we're going to copy and paste to the side. So I, 2, and 3, and J, -3, -2. Do you see what I did? Okay, so why did I do it? Because I said so. That there's not any rhyme or reason to that. It's just, it makes the shortcut work, okay? All right, here we go. So what we're going to do, starting at I, is we're going to multiply down on the diagonal. Do y'all see that? This diagonal right here is going down. So what is -1 times -3 times I? 3I. All right, Britney Spears. Oops, I did it again. Multiply down on the diagonal. Positive 3J hit me, baby, one more time. -4K. Everybody okay with what I've done so far? Yes? Okay, so now what I'm going to do is I'm going to switch color. And I'm using red for a reason. What happens when you go in the red? You're in the negative, right? Like in your checkbook, if you go in the red, you're in the negative. And the reason I do this is because when you multiply going up, whatever answer you get, you have to change the sign. You have to multiply by -1, okay? So what is 3 times -3 times K? -9K, but it's going to be positive 9K because I have to change the sign. Okay? Okay. Whoops. What am I doing? Draw. Red. Here we go. Next one. Going up. Next one. Going up. What is the next one going to be? Plus 2I. And the last one? Plus 2J. So far, so good? I haven't lost anybody yet? I'll keep trying. And now let's do green, because I like green. And let's go this and this right here. And let's put a big old plus sign. And now to finish it off, you're going to take the top row and the bottom row and you're going to combine like terms. And you're going to do it I, J, K, alphabetical order. So I've got 2I plus 3I. 6I? Oh, where'd I get 6 from? I think I multiplied. Is that better? Okay, next I've got 2J plus 3J. And last but not least, I've got 9K minus 4K. And that is V cross W. That is the vector cross product. And let me check the book to see if that's true. Oh, its answer's not in the book. Anybody have any questions about that? Oh, this guy?
Yeah.
Do you see that he was copied from here, and so he was involved in this process? Over here, he didn't get used. All right, so I think what I'd like to do, since you probably should see that at least one more time to make it sink in, let's do W cross V, and I'll prove that you don't get the same answer. W cross V. And again, the way that you do the cross product is you always start with I, J, and K along the top. And then which vector goes next? W. Whichever vector is first goes next. So that's going to be 3, -2, -1. And then vector V, that's going to be 2, -3, +1. So far, so good? And then the next step, you take the first two columns, and you copy and paste outside. I, 3, and 2. J, -2, -3. And then let's see. I'm going to use colors for this. Blue going down. And red going up. Blue going down, red going up. I'm looking at -2I minus 2J minus 9K. And I need somebody to verify if that sounds correct or not. Down, down, down. All right, now going up, up, and up. I'm looking at +4K. I'm looking at -3I and -3J. Don't forget, when you're going up, you got to change the sign. Whatever you get from the multiplication, you're going to have to change the sign. Everybody agree with that? Then we're going to take those two results, the top and the bottom row, and we're going to combine like terms. How many I's do I have? How many I's do I have? I've got 2 I's right here, yeah. 2 I's. No, up here it's negative 5I. Hmm? I'm not blind. Yeah. How about J? How about K? Now let's compare those.
Is it always going to be the opposite like that?
It is. And let me see if I can explain that real quick. Do I have anything clear? Okay, let's see if I can explain what's going on here. Y'all know that a three-dimensional vector is going to have a starting point and it's going to go off into space somewhere, okay? So let's say, okay, you can use your imagination, right? Okay? So let's say that we've got this corner is a vector running into this corner here. And then this corner is a vector running into that corner. And y'all can see that they meet at a right angle. So what the cross product is finding, it's finding the vector that is perpendicular to both of those vectors in a certain direction. So if I run this vector in and this vector in, then this corner is perpendicular to both of them, right? So one of the vectors that we found is going from that point down, and the other one's going from that point up. And so that's why they're always opposite, is because they're basically in the same direction, but one's going north and one's going south or east and west or whatever, okay? Got it? Questions?
That could be a way to check your work if they're not matching, if they're not opposite of each other, you may get something wrong there.
Exactly. If you do both of the dot products and they're not opposites, then yeah, you screwed something up. I will say that the Casio does this for you. The Casio FX115ES Plus. And I'm going to walk through it because I have a little bit of time left. How many people have a Casio? Okay, it's about half or more, so I think it's worth spending a little bit of time on it. So what you want to do is you want to push mode. Go ahead, mode. And do you see number 8 is vector? So hit number 8 and then select number 1 for vector A. And vector A for our case is going to be vector V. Got it? And so hit number 1 because it's a three-dimensional vector. And then I need you to put in 2, -3, and 1. So that's going to be 2 equals, -3 equals, and 1 equals. Got it? And then I need you to hit mode 8 and number 2. Now we're going to do vector V. Again, it's a three-dimensional vector, so number 1. And then I need you to put in 3, -2, and -1. 3 equals, -2 equals, -1 equals. So far, so good. Yes or no? So, Casio people keeping up? Itzel, you doing okay? Okay, just checking on you. Now, let's push clear. AC is clear. And let's push Shift 5. And number 3 is vector A. And then hit the times key, the multiplication key, and then shift 5. Where's vector B? Number 4 equals. And it should give 5, 5, and 5 across. Oh, it's a lot of button pushes, yeah. It's almost easier to just go ahead and do it by hand. But I did want you to know the Casio does it, okay? It'll do a cross product. But the nice thing about the Casio, once you get vector A and vector B put in there, it's easy to do both cross products because now all you have to do is hit clear and go back to shift 5, choose vector B first, times mode 5, and then choose vector A. You can actually do both of the cross products once you get that put in there. Does anybody have any questions? All right, so what I'm going to do, I'm going to go ahead and shut this recording down.